So 3.5 is on solving equations. And we're going to do some more regression. Okay, so we're going to finish up all the regression stuff that we're ever going to do. Well, except for trig. All right, so we're going to solve equations. And we'll do regression. Some scatter plot stuff. So we're going to have two types of equations to solve. Okay, the first type is we're going to solve some exponential equations where the variable is the exponent and we have to figure out what that is. Okay, so here we go. First thing you want to do is you want to isolate the power. Isolate the power. Get the base to the exponent all by itself. And then after that, you're going to take the log of both sides. That's going to be the most important step there. Take the log of both sides, because whatever you do to one side, do unto the other. It's the golden rule of algebra. Okay, so let's start. Here we go. I've got, like 5 of these. I hope you can. I think I'm going to skip the first one. It's too easy. Number 1. Don't do that. All right, here we go. 3 times 2 to the x minus 4 minus 6 equals 52. All right, that's an equation to solve, isn't it? So we need to figure out what x is, and we're going to round all our answers to 3 decimal places. So what we have to do first, we need to isolate the power. Okay, so this right here is the power part, and we got to get all the other stuff around it out of the way. So first step is add 6. Okay, add 6 to their side. So we get 3 times 2 to the x minus 4, and never make that 6 to the x minus 4. That's not right, okay? It's exponents and then multiplication. And so I get 58. And then we divide by 3. 58 divisible by 3? No. How'd you do that? Did you add them up? No? Oh. Have you ever known that about 3s? If you add up the number and that number's divisible by 3, like if I do 5 plus 8, I get 13. 3 doesn't go into 13. But if you do like 108, 3 goes into 108 because it adds up to 9. Yeah, that works for 3s and 9s. 9s too. Isn't that cool? No one ever taught you that.
I knew that.
You knew that though. Good. So if you had something like 1,207, 2. Like, is that divisible by 3? Yeah. You add up all the numbers and it's 12 and 3 goes into 12. Isn't that cool? I love that. All right, divide by 3. And so you get 2 to the x minus 4 equals, then I'm going to leave this as 58 thirds because it's going to be a decimal. All right, so we did the first part. We isolated the log and now, or the exponent, and now what we're going to do is take the log of both sides, okay? So I like to take log base 10 of both sides. Some people like to do log base 2, which is fine. Some people like to take natural log of both sides. It doesn't matter. Whatever log you take of both sides, just make sure it's the same log. So I'm just going to use base 10 because that's the way I'm used to it. My calculator has log base 10. And so when you do that, the reason why we do that is because we have that property that tells us that now we can move the x minus 4 to the front. Okay? So when we move that to the front, it's going to be in parentheses, x minus 4 times log 2 equals log of 58 thirds. Okay, we're solving for x, so this is multiply. Let's go ahead and divide both sides by log 2. I get x minus 4. I don't need the parentheses, do I? I don't even like those parentheses there. I'm going to erase them. There we go. All right, x minus 4 equals, and don't cancel out the logs. The logs don't cancel each other out, because sometimes people will do that. Divided by log of 2. Okay, now the rest is just basically you're going to use your calculator. Okay, from here, you don't have to show any more steps. You do need to show your work, though. Make sure you're showing your work when you do these in your homework over the weekend. So log of 58 thirds, close the parentheses, okay? Because it's log of that divided by log of 2. And we get 4.273, and then we're just going to add 4 to the other side. So x would be approximately 8.273. Okay? So I divided the logs and then I add 4 to the other side. You can also check your answer, too. Here's a nice way to check your answer. If you have it in your calculator like that, you can go 3 times 2 to the answer, you know where the answer key is? It's the negative sign. Answer minus 4, and then minus 6. And I should get 52. Yes, it works. So you can check your answer very quickly. All right. So far, so good. Do you remember doing these last year? Yeah, we did some of these. They were a little easier than ones we're going to do this year, but, you know, that's the way it goes in this class. All right, number 2. The next one, we're not going to use a calculator. Okay? So here we go. No calc. This would probably be on the no calculator section. You have 27 to the negative 2x plus 6 equals 1/9 to the 5x. All right, you get to a problem like this, and they say you can't use your calculator, and you look at that and you're like, really? Holy cow, how am I not going to use my calculator? All right, so this is what you want to do. You want to change both sides to be the same base, okay? I can rewrite 27 as 3 cubed. Do you agree with that? 27 is 3 cubed, and this is still to the negative 2x plus 6. Did I change anything? Not really. Just kind of rewrote it, okay? Over here, I can change 1/9 to a base of 3 by doing 3 to the what? Negative 2. Still raised to the 5x. All right. So now, if I have a power raised to a power, what do we do with those things? We multiply them. Okay? So this is going to become 3 to the negative 6x plus 18. And over here, this is 3 to the negative 10x. And now I'm ready to solve. Because I have 3 to the stuff equals 3 to the stuff, guess what? Stuffs are equal. Yes, mathematical term there. Equals negative 10x. Okay, and now we solve that. I love stuffs equals stuffs. All right, add 6x to the other side. 18 equals negative 4x. Divide by negative 4. 18 over negative 4 is negative, you can leave it as a fraction. Negative 9/2, negative 4.5, whatever. Would you be able to do something like that on a non-calculator? Yeah. Some of you said yes. Good. That's hard, though. But I'll never give you anything that's not going to become the same base. You know what I mean? Because then you can't do it that way. This is like a special one where you set it up so that it does work. All right, that's a fun one. That's probably my favorite problem of the day. All right, number 3. Number 3. Ooh, maybe this one is. I don't know. They're all just so good. E to the 2x minus 3e to the x plus 2 equals 0. All right. We've got x's in different spots. We can't add those up. They're different. When you look at something like this and you see a trinomial, what do you think of doing? Yes. Yes, quadratic formula or factor, if it factors. Yes, we're going to factor this. I know, right? Isn't that fun? We're factoring algebra 2. We're going to play bingo today. It's so fun. All right, so here we go. E to the 2x. Now, what I'm going to do is I'm going to do e to the x times e to the x. That's going to give me my first term if I FOIL this out. Because remember, what do you do? The exponents, you add them. So x plus x is 2x. And then what times what's 2 adds up to negative 3. Well, there's only one option. A negative 1 times a negative 2. And if you see the outside, if I FOIL this out, is negative 2x. Inside is negative 1, or negative 2 e to the x. Negative 1 e to the x, that's where I get my negative 3 e to the x. And I just factored it.
Where'd you get the e to the x? Sorry.
That would be breaking this up into what times what gives me e to the 2x. So e to the x times e to the x is you add up the exponents, e to the 2x. It's like if I had x squared and I was trying to figure out what times what is x squared. That's just x times x. So this is just e to the x times e to the x.
Oh.
Yeah. All right, so now what we're going to do is we're going to set these equal to 0 and solve. So we've got e to the x minus 1 equals 0. Let's go ahead and solve this. Add 1 to the other side. Ooh, without taking in the log of both sides, can you solve that? Yeah, 0. E to the 0 is 1. Okay. Let's do the other one. E to the x minus 2 equals 0. Add 2 to the other side. And then here, what you want to do is you want to take the natural log of both sides. Okay? So we'll take the natural log of e to the x equals the natural log of 2. Bring that x to the front, and Lenny, he's 1. He's always 1. Just a cute little baby. And then we get x equals natural log of 2. And you can leave it like that. That's actually a better answer than figuring it out on your calculator. Okay? You like that one? That's a good one too. All right, let's do one more of these exponentials, and then we'll get to log equations. All right, number 4. This one's got some work, and it's not slight. Okay, 1,025 over 8 plus 9 to the 4x equals 5. All right, we're going to solve here. Okay, so we're solving algebraically, by the way, because some people are like, oh, just plug in your calculator, find the intersection point. Yeah, we could do that with everything, but we're not going to. So here we go. Put this over 1. That might help. And what are we going to do? Cross multiply. Well, yeah, when you put that over 1, you go, oh, okay, let's cross multiply. So we get 1,025 equals, and we're going to take that 5 and distribute it to both terms. So that would be 40 plus, do not do 45. It's not 45. It's 5 times 9 to the 4x. Okay? All right, so then the next step is we're going to do what? Subtract 40. Subtract 40, and we get, oh, that's so funny. I left it 5, and I divided it by 5. Did anyone do that? You didn't distribute? You could have done that. I did that earlier. Okay, 1025. The rest of it's pretty much in your calculator. 985 equals 5 times 9 to the 4x. We're trying to isolate the power. We're trying to isolate this right here. So we want to divide now by 5. So you get 197 equals 9 to the 4x. And then you can take the log of both sides. I usually do log base 10. Some people like to do log of whatever the base is here. Like this is base 9. I'll show you that because that's an option. If I did log base 9 of 197 equals log base 9 of 9 to the 4x, and I move that 4x down, especially those of you who have calculators that will do any base, this might be a good option for you. When you bring the 4x down, what's log base 9 of 9? It's just 1. And then you just divide by 4. Okay? So that's an option. I don't know. I like to take just basic log, or just log base 10. But then I would need to do alpha window, sorry. Alpha window number 5, log base 9 of 197, and then I'm going to divide by 4. So, does anyone like that option? Or no? Did that confuse you? Hopefully it didn't confuse you. 601. There you go. So if you did log base 10 of both sides, then you divide by log 10 of 9, and then you do it that way. It's the same idea. Okay, are you ready? That was 13 minutes. Did it feel like longer than that? Don't answer that. All right, next one, B. Now we're going to do some log equations. Now log equations are harder for a few different reasons. Logs in general, a lot of people don't get logs. Like, what's a log? It's an exponent, okay? Remember that. Also, though, when you talk about the graph of an exponential, x is all real numbers. The domain is all real numbers here. But when you do the graph of a log, the domain is restricted. Domain is x has to be greater than 0. Okay? So what that means is we could get extraneous solutions here. So you have to check your answers. Okay? Extraneous solutions are possible. Not for exponential because the domain is all real numbers. But because the domain's restricted on log equations, you need to check for extraneous solutions. They will show up. The other thing is, to solve a log, you want to rewrite in its exponential form. Okay? You do this already. Okay? When I gave you something like this, log base 2 of 8 equals question mark, right? Okay, to evaluate that, you're not like, oh, the log of base 2 of 8. No, you're rewriting this in your mind 2 to the what equals 8. You're rewriting it in its exponential form, okay? And you're getting that equals 3. So this is the same thing as that. So that's what you want to do. You don't do something to both sides, like in the last one. Oh, let's take the log of both sides. So that's what makes these a little bit tough. All right, let's get to it. Number 5. Here we go. Start you with a nice simple one. Log base 2 of the square root of x minus 1 is equal to 4. Okay. So some people wanted to go, oh, let's just square the whole thing. No, you cannot do that. Okay. This is the log of this inside of here. It's the log's on the outside. The log is the first step to get rid of. Okay. And you can't just divide by log 2. That doesn't make any sense. You want to take this and rewrite it in its exponential form. Okay. So we're going to do 2 to the 4th equals that stuff, right? The base is 2, a log equals the exponent, and it's equal to the square root of x minus 1. Do you remember doing this last year? You did it last year. It's tricky. Someone else liked to do this. They just put a base 2 on both sides and then got rid of it like that, but that doesn't really make sense, but it worked for them. All right, so then you get 2 to the 4th, which is 16. Equals the square root of x minus 1. Let's go ahead and square both sides. Does anyone know 16's perfect square? Nice! 256. Very good. X minus 1. And then add 1 to the other side. 257. I only know all the way up to 13, and then I stop there. Okay, let's do another one. Number 6. Let's do, ooh, this is a good one. Log base 3 of 5x minus 1 equals log base 3 of x plus 7. Okay, here's a log equation to solve. We're trying to figure out what x is. This is one of my favorites because you know what I'm going to say. Does anyone know what I'm going to say? No? Stuff equals stuff. Yeah, it's a good one. Stuff equals stuff. If I have the log base 3 of something equals the log base 3 of something, well, those somethings have to equal each other. To figure out what's x going to be to make them equal to each other. And so I go ahead and solve this. Can you solve this in your head or no? Subtract x, add 1, x equals 2. Okay, that should make sense, because if I plug 2 in, I get log base 3 of 9 equals log base 3 of 9. True statement. And make sure we're checking these. I totally forgot to check this last answer. Yeah, it's okay. All right, number 7. We're cruising. We're doing so good. Oh, here's a good one. 5 plus 2 times the natural log of x is equal to 4. Okay. We're going to isolate the natural log part. So the first thing we do is subtract 5. Okay, subtract 5. So I get 2 natural log of x equals negative 1. And then divide by 2. So natural log of x equals negative 1/2. And here's where people will halt and they'll be like, oh, how do I do the rest of this? I don't know. Okay, this is just solving a log. You're trying to figure out what x is. So we're going to take the base and we're going to go e to the negative 1/2 equals x. That's the trickiest part. Try not to forget that. And then you'll go to your calculator and we'll type in e to the negative 1/2. Uh-oh. Okay, fix it. So x is approximately 0.607. Okay? And check to make sure that that's not extraneous. If I go back up to here and I say, what can I plug in for x? I can plug in anything that's positive in for x, and I'll be okay. All right, how many more? 2 more, and then we're going to do the regression part. We're getting there. Number 8. Now what happens when we have separate logs like this? Log base 3 of x plus log base 3 of x minus 8 equals 2. Okay. I can't do stuff equals stuff on this one because I don't have a log on the other side. So what I need to do is I need to combine my logs together, okay, using our properties. So that's why we do properties first and equations second. So let's combine those together. There's a plus in the middle, so we're going to multiply. I have log base 3 of x times x minus 8, and that's equal to 2. Everyone okay with that step? Yeah, so if you have multiple logs, just get them all together, use your log properties. And now we have the log of something, so we can get rid of the log by writing this in its exponential form. So we'll go 3 to the second equals x times x minus 8. All right, so you get something that you need to solve, and this is 9 equals, and we can go ahead and distribute x squared minus 8x. Anytime you have x squared, you have a quadratic to solve. You need to solve it using any method that you like to solve quadratics, okay? So some people, first of all, we need to get our quadratic equal to 0. Some people like to use quadratic formula. Some people have a quadratic formula on their calculator, which is fine. You have a program. Yeah, if you need it, I can always link it over to you. Did Mr. Edlin teach you how to do that? Yeah, it was pretty good. And you guys typed it all in yourselves? Oh. I have this cord that goes from mine to yours, and I send it to you in a second. Yeah. But I liked it because he walked you through it, and he did like the program of it. Have you ever done any programming before? No? It's interesting, huh? Have you? Yeah, I took a programming class in college. It was hard. Yeah. Okay, I like to factor that. That's my favorite. I love factoring. So what times what's negative 9 adds up to negative 8 would be a negative 9 and a positive 1. So then I get x equals 9 or negative 1. Now be careful. Let's check. Go back to the very original equation. Can I plug in 9? Sure. Can I plug in negative 1? No. Negative 1 is extraneous. So you need to go over here. I want to see that you got it, though. I don't want to see that you cross it out. Okay? All right. Do we need to do that one? I don't think we do. Nope. All right, let's go on to the last part, part C. And you're going to need your calculator. And we're going to do regression equations. Okay? Regression equations. Now, we have learned quite a few different regression equations. You started off in Algebra 2 learning linear, right? And you had to find the line of best fit. And we did that last year. We also did quadratic last year. And we did higher degree polynomials like cubic and quartic. So we've done all of those so far. Beep, beep. This year, we added in exponential regression. And what was the other one? Do you remember? Logistic. Okay, we're going to add in one more. So you're going to have to know how to do all of these, but it's the same steps, right? So if you go to Stat over to Calc, and you scroll down, we're taking a little walk down memory lane. Yep, did all those. We don't do number 8 though. That's some weird line they do in statistics, so don't worry about that. We did exponential. We don't do power regression in here. Logistic we did, and now what we're going to do is, I passed it. This one, number 9. We're going to do natural log, okay? So logistic is not the same thing as natural log. So we're going to do natural log, which on your calculator it'll say ln regression, okay? Logistic is not a log. I know the word log is in logistic, but logistic's exponential, as you know. So natural log is not. All right, so here we go. Last one. What number? Number 9. I'm going to give you some data. Okay, so let's say we have x, y, and x is 1, 2, 3, 4. Super original. And y is 3, 4.4, 5.2, and 5.8. And so what I'm going to have you do is I'm going to have you do a couple of things. We are going to find the line of best fit. We're going to find a quadratic regression, an exponential regression, and you're like, great, a natural log. Okay? So here we go. It's only 4 data points, so that's not going to take you a long time. Finding all of these, and then I want you to write down the r or r squared, depending on which one it is. Okay? So go ahead and go to Stat, edit and put your data in, your 4 points. And then we're going to find each of these separately, and we're going to talk about which one's the best one. Okay? All right, so I'm going to go to Stat Calc. Number 4, linear regression. And there it is. So I get y equals 0.92x plus 2.3. And the r value on that is 0.98. That's not that bad. But we're looking for something better, right? Okay, let's go to quad regression. So Stat Calc, number 5, quad regression. And we get y equals negative 0.2x squared plus 1.92x plus 1.3. Now, for r, we really need r squared here. R squared is 0.998. That's really good. That's better than our line. So we can kind of rule out the line for now. Okay. Now let's do exponential. So go to Stat Calc, EXPREG, number 0. Ew, not good at all. So we get y equals, A is 2.62, and then B is 1.239, whatever, to the x. And then here, r squared, I should have written r squared down for the line to compare r squared, but that's okay. R squared is 0.92. Wow, in some families, that's a fail, right? If you get a 92% on your math test, whew. Yeah, some people will be mad. All right, and then finally the natural log. Stat Calc, which is the new one for today. So guess what? It's probably going to be that one. Were you thinking that all along? Yeah, you're right. You're right. All right, natural log is number 9. And so, oh, look at that. Look at that. R squared value, 0.99999. Oh, so good. All right, so there it is. Y equals, and we'll just round up to 3 plus 2.01 natural log of x. So let's go ahead and go to our calculator and let's see how good that is. So go to y equals and turn your plots on and hit zoom 9. And you know, if you did that first, you could probably rule out some things. Like, you know, it's not going to be exponential. This is not exponential. You might be able to tell that that looks like a log graph, right? It's almost linear. I could have made a pretty decent line, or it could have been quadratic, you know, but the natural log was the best one. So let's go ahead and write 3 plus 2.01 natural log of x. And if you wanted to, you could do that, you know, regression equation, put it in there. Just make sure that's the last one that you do. And look how many points it goes through. I mean, it pretty much, it goes through all of them. It's 0.99. Okay? If I put the quadratic one in yesterday when I did this problem. I did negative 0.2x squared because the quadratic was a pretty decent model. 1.92x plus 1.3. It touches a lot of them, but see, it kind of messes up a little bit there. But that one was pretty good too. So, but the natural log was the best one. Okay, you're going to have something like this on your test where you have to find a couple of them. I won't make you do a whole bunch. That's a little bit too much.